I'm Jairo Rivas, and our senior design project is a virtual reality survival game with an adaptive island AI called A-Island. The game will be created using the Unity 3D game engine. The player will start the game with nothing, alone on an island, and must gather resources and build tools to survive. What makes our game unique is that the island itself will be adapting to the player's behavior. This means that based on what resources are gathered and what's built with them, the island will change in appearance, the resources it makes available, and the creatures that respond.
Hi, my name is Ramiro. Jairo and I have played other survival games, and they tend to get a bit repetitive. By the time you finish the game, you know the map pretty well, and you know where to go to find all the resources you need to survive. So surviving becomes easy and predictable. So most of the time, there's no need to play again because the experience is going to be the same. But with A-Island, we plan to remove that predictability and create a different experience every time you play. For example, at the beginning of every new game, a randomly generated island will be created for you using procedural landmass generation. We'll also be introducing an adaptive island AI system that constantly changes the environment around you, which will make surviving more challenging and unpredictable.
Here's a simple implementation of procedural landmass generation. The island is created using what's known as Perlin noise. Essentially, Perlin noise allows us to make a randomly generated height map that you can see here. This algorithm allows us to control the main characteristics of the height map while still keeping some level of randomness. Because of this, we can generate an almost infinite amount of unique islands.
This is a flowchart describing the main flow of our game. We begin by choosing between starting a new game or loading a saved game. If you start a new game, a randomly generated island will be created using our procedural terrain generation algorithm. Then, the game will start. If you choose to load a game, then the saved island will be reloaded and the game will begin. Once the game begins, the game's flow can be divided into three parts: the resource and building system, the island AI system, and the real-time reconfiguration system of the island.
This is a flowchart of the resource and building system. During the game, the player will be collecting resources. The resource manager will keep track of gathered resources. It tells the player how much of any particular resource they have collected. The build system will serve as a directory of tools and structures that the player can create using the gathered resources. This will continue throughout the game. Meanwhile, the Island AI system will be collecting important data regarding the player's resource collection and usage. It will use this to determine how the island will adapt.
The Island AI system will take information from the resource and building system to determine whether or not the player's behavior is considered threatening. If the island perceives the behavior as threatening, it will react. It will change scenery, the resources it makes available, and the creatures it spawns.
Before we begin development, there are three major challenges we need to overcome. The first one is that we need to learn how to program using the Unity 3D engine. We plan to do this early in the summer. Next, we need to learn how to procedurally generate random islands. We already started research on this, and we started creating simple versions of the island. We plan to come up with a more final implementation during the summer. Finally, our biggest challenge will be to create the Island AI system. We want the Island AI to be the player's biggest obstacle, so we plan to spend most of our time developing this.